Hello, welcome to this video which is on simplifying algebraic fractions, and this is the first video in the C2 series. Now we're going to look at a series of fractions and how we can simplify them, if we can indeed simplify them, and these are all going to involve at least one quadratic term, either as the numerator or the denominator. So this first example, we have a quadratic factorised as the numerator, and we can see, hopefully, that the factor x minus 1 on the numerator is also a factor of the denominator, because it is in fact the entire denominator. So I can cancel x minus 1 on the top with x minus 1 on the bottom, which will just leave me with x plus 3 on the top, 1 on the bottom, but that can simply be be written as x plus 3. Now this second question, I have the numerator as a quadratic unfactorised, and the denominator is x minus 1 again. So if this is going to simplify, I need to be able to find a common factor between the numerator and the denominator. And because the only term I have in the denominator is x minus 1, that gives me an indication that x minus 1 is going to be a factor for the numerator. So let's assume it is. Can I find something that will multiply by x minus 1 to give me x squared minus 2x plus 1? So to get the x squared I must multiply by x, and to get plus 1 on the end I must multiply by negative 1. And let's just check that gives me negative 2x. So if I look at expanding the x terms, so minus 1 times x is minus x times minus 1 is minus x, gives me minus 2x. So that is indeed correct. And then I've got x minus 1 on the denominator as well. And now I've got a common factor. I can cancel x minus 1 with x minus 1, which just leaves me x minus 1 over 1, or just x minus 1. Okay, so this third question, I've got two quadratics. So if this is going to simplify, I'm going to be able to factorise both of these two quadratics, and one of the brackets is going to be the same on both the denominator and the numerator. So it doesn't really matter which one we pick first, and neither of them look particularly difficult to factorise because they've got a coefficient of x squared of 1 in both cases. So I'm going to start with the top. So if it factorises, then each bracket is going to begin with an x. I need a product of 6 and a sum of 5, so that tells me it will be 2 and 3. So on the denominator, again, I've got a coefficient of x squared of 1, so it tells me both brackets should begin with x. Everything's positive, so they're both positive. So I need two things with a product of 2 and a sum of 3, so that will be 1 and 2. And then indeed I have a common factor here of x plus 2, so I can cancel x plus 2 on the top, x plus 2 on the bottom, and that leaves me with x plus 3 over x plus 1. Final example, I've got a far more difficult quadratic to try and factorise on the numerator this time, because the coefficient of x squared is not 1. So I could go through and use the methods we learned in C1 for factorising that, but what I'm actually going to do instead is I'm going to just factorise the denominator first, because this one is a much more straightforward thing to factorise, because the coefficient of x squared is 1. So I need two things with a product of 5 or negative 5 and a sum of negative 4. So that will be negative 5 and positive 1. Now the reason I've done that first is because one of these two must be common with the numerator, otherwise it wouldn't factorise. And looking at the information I have here, I suspect it's going to be x minus 5. So if it is x minus 5, the other bracket must begin with 3x to give me 3x squared, and to give me minus 10 on the end, it must be plus 2. So let me just check for the x term to see if that's right. If it's not, then this must be x plus 1, and I just repeat the process with x plus 1. So minus 5 times 3x is negative 15x, and 2 times x is 2x. So negative 15x and 2x does indeed give me negative 13x. So now I can simplify, and that leaves me with 3x plus 2 over x minus 5.